Hello students, welcome to Sources classes. Today I will explain, this is a very interesting and new type of class I have come up with. In this class I will tell you about all very complicated and sometimes useful diagrams. But you know, in economics diagrams there is a main problem. Most of the cases the books don't just solve it properly. They just draw it like this, and this is this, and solve. Then there's a curve, and you are transfixed. How this is going? Will it touch here? Will it end up where it starts? We don't know. So my session today will be giving you some idea on the basis of this kind of diagrammatic representation. So I'm choosing a blue color. First is TU plus marginal utility. So total utility and marginal utility diagram in a single case. So let's solve it. So here I'm just pointing out. So this is your total utility curve. Remember that total utility will start from origin. That's it. It will start from origin. No upside, no downside, no, not in the left side. So total utility here. And you see there's a bending point. So this is the maximum possible point achievable. You go and you do this step. This is called a vertical summation in economics way. A vertical summation. So this is the vertical summational pattern. So in this way, what happens? You draw this curve. This thing goes down, and your marginal utility will come like this. Okay, so the marginal utility comes like this and it reaches over here. So the maximum point of the curve, which is the total utility curve, and the minimum point here. So marginal utility will reach 0, mu equal to 0 when tu equal to max. That's it. So this is a simplistic idea of this diagrammatic representation. Remember that in these videos I will not be going for full explanation of the curve, only how to draw them. Now let's go to the second one. Now the second diagram comes into play, and this is a very important one, IC and budget line. Normal this type of diagram you have seen like this. This is your IC, this is the budget line, and this is the point of tangency. That's it, your job is done. But there is a special condition. What happens if there is a corner solution? Okay, so what is a corner solution structure? So this is a corner solution based pattern. This is the budget line. The consumer buys any one product. So this is the IC, this is the structure. And if there are more than one IC, so that's it. Just like that. And if the consumer prefers the A in this case, then the diagram will be like this. And the other curves will be like this. So this is the pattern based idea for ICs. But what happens if the IC itself is not convex to the origin but concave? So concave IC. So in case of concave IC, it will be like this. So line will be drawn like this, and your diagram is this. That's it. So this is the point of intersection, and this is the diagram. So here also higher, lower. So the concave part is tangent with the curve. Next one. What happens if the IC itself is L-shaped? This is your L-shaped IC. Then the budget line is like this. That's it. In the L-shaped IC also you get a tangency point like this, and your job is done. So this is a small introduction about the diagrammatic representation. In the next video I'll be doing some more complicated graphs.